So this is 1.5 part 2. So we're going to be simplifying radicals. Some of those radicals will have a negative in it, which makes them imaginary numbers, which makes them complex numbers. So it kind of ties in what we've been doing in part 1. So if we have a negative under our radical, we always want to take that out and turn it into an I. So what do you think the square root of negative 25 is? 5i. Perfect. So we have plus. What's the square root of negative 36? 6i. Awesome. Now that negative comes out and turns into an I. It's not like a negative 6. The negative is the I part. What is 5i plus 6i? What is it?
11i.
11i. Let's do number 2. So number 2, we don't have perfect squares, so it just may take us a little bit more time to break it down. What are 2 factors of 27? 9 and 3. And 2 factors of 9? 3 and 3. I'm circling 2 of a kind. So what's going to come to the outside? 3. And what else? An I. So 3i comes to the outside. What stays on the inside? 3. The 3 that didn't get circled stays on the inside. Let's break down the other one. We're going to take the negative out, turn it into an I. What are 2 factors of 48?
12 and 4.
12 and 4. Perfect. 2 factors of 4?
2 and 2.
2 and 2. 2 factors of 12?
4 and 3.
And 2 factors of 4?
2 and 6.
What would we circle here? I have a group of 2's here and a group of 2's here. So what is going to come to the outside? 4. What did I already have on the outside? Negative 3i. So this would be what on the outside? Negative 12i. Perfect. That 4 that we take out, we multiply to the 3. And then what stays on the inside? What didn't get circled?
3.
The 3. Now let's break down the square root of 12. 2. Well, what are 2 factors of 12?
4 and 3.
4 and 3. 4 breaks down into 2 and 2. So what comes to the outside?
2.
2. And what stays on the inside?
3.
3. All right, so let's simplify. And we want to put it in standard form. Are all 3 of these like terms? No, which 2 are like terms?
3i and 12.
The ones with the i's. So we can combine those together. What would our real part be here? What would come first? 2 square root 3. That doesn't have an I, so that's our real part. So that one comes first. Now we can combine the 3i root 3 minus 12i root 3. So we're just combining the coefficients together. What's 3 minus 12? Negative 9i root 3. And that would be our answer. So we have to simplify each radical, figure out what our like terms are, combine our like terms, and put it in standard form. Let's do number 3. So we want to break down each radical first. What are 2 factors of 50? 25 and 2. And 2 factors of 25? Awesome. So we'd circle the 5's. What's going to come out here? 5 what? 5i. Square root 2. Because the 2 didn't get circled. Perfect. Let's do the same thing with the second one. What are 2 factors of 45?
15 and 3.
15 and 3 works. You could have said 9 and 5. That would also work. What are 2 factors of 15?
3 and 5.
3 and 5. What would we circle here? 3's. What comes to the outside?
3 square. 18i.
Awesome. We take out the 3. We have to multiply it to the 6. So that would turn into 18. We also have an I there. Don't forget about the negative. So 18i square root 5. Now let's do it with the third one. What are 2 factors of 75?
25 and 3.
25 and 3. 2 factors of 25?
5 and
5 and 5. We circle the 5's. So what's going to come to the outside?
Negative 15i.
Awesome. We multiply the 5 and the I times the 3, so it'd be negative 15I. And what stays on the inside?
3.
3. Do we have like terms here?
No.
No. Do we have a real part here?
No.
No. So it's all imaginary, and we can't combine any of these together because they're not like terms because the radical is different in each one. So this would be our final answer. So because each of the radicals are different, we can't combine them together. And then it doesn't matter what order we put it in because they're all imaginary. Remember, you'd always want the real part to come first, but we don't have a real part here. All right, next, we're going to talk about dividing complex numbers. When we have a complex number in our denominator, we want to multiply the numerator and the denominator by the conjugate of the denominator. So if I had something like 5 plus 4i, what's our conjugate of this? Do you remember what conjugates are? It would be 5 minus 4i. Perfect. Same numbers, but the sign in the middle changes. What if I had something like negative 3 minus 2i? What would the conjugate of this be? Negative 3 plus 2i. So only the sign in the middle changes. So these would be conjugates. So example 3. Let's look at A. So we want to get rid of the imaginary part from our denominator, so we need to multiply by the conjugate of the denominator. What's our conjugate of the denominator for A? 1 plus 2i. Remember, it's the conjugate of the denominator. And whatever we multiply to the bottom, we have to multiply the same thing to the top. So we're multiplying the conjugate of the denominator to the top and the bottom. How do I multiply 3 plus 5i times 1 plus 2i? I FOIL. So let's FOIL out the top first. 3 times 1 is 3. 3 times 2i would be 6i. 5i times 1 would be 5i. And 5i times 2i is what? Awesome. You're one step ahead of me. But it would be 10i squared. And what happens when we have I squared? It changes to negative 1, so it would be minus 10. Perfect. Let's simplify our numerator a little bit by combining like terms. What's 3 minus 10? Negative 7. And 6i plus 5i? Plus 11i. So that would be our numerator. Now let's multiply the denominator. There's two different ways that we can multiply our denominator. We can FOIL it, or we can use our conjugate shortcut. The conjugate shortcut is a squared minus b squared. So the first term, this would be our a, this would be our b. First term squared minus the second term squared. So it'd be 1 squared minus 2i squared. So 1 squared is 1, good job. What is 2i squared? 4i squared. What do I do when I have an I squared? Change it to be negative 1, which changes the negative 4 to be positive 4. And what's 1 plus 4? 5. So our denominator would be 5. If you FOILed the denominator out, you'd get the same answer, but the conjugate shortcut is just kind of a shorter way because the outer and the inner, when you multiply it by conjugates, cancels. So you can just do the first times the last. Don't forget, when it's 2i squared, you have to square the 2 and the I. What would I multiply here?
Negative 4i.
We can do negative 4i, that would work. we could also just multiply 4i here. Since we don't have a real part, we just want to end up with an I squared on the bottom. So we could multiply negative 4i or positive 4i. We can do negative 4. But just make sure whatever you're multiplying to the bottom, you're multiplying to the top too. So how would I multiply 7 plus 3i times negative 4i? What would I have to do? Am I foiling? Do I have a binomial times a binomial? Do I have to foil?
What? The bottom one?
The top.
I mean, just multiply the negative 4i.
So we distribute?
Yeah.
Yeah. So what's 7 times negative 4i? Negative 28i. And 3i times negative 4i? It'd be negative 12i squared. And what do we do with the I squared? Change it to be a negative 1, which makes it a plus 12. Is this in standard form?
Yeah. No.
No. How would I rearrange it to be standard form? Just flip it. 12 minus 28i. So that's our numerator. All right, let's multiply our denominator. So it's 4i times negative 4i.
16.
Negative 16i squared, and what does the I squared change to?
Negative.
Changes to negative 1, which makes it a plus 16. So positive 16 goes on the bottom. So this would be our answer, but can I simplify this?
Yeah.
If we're going to simplify it, we need a common factor in all 3 of our whole numbers. What goes into both 12, 28, and 16? 4. So we can divide them all by 4. So this would be 3 minus 7i over 4. What do you think I could have done in the beginning? So looking at our original question and the answer we got, what do you think I could have multiplied by in the beginning instead of negative 4i? Any suggestions? So in the beginning, we could have just multiplied by an I, because we don't have like 2 terms like we did in A. We only have that 4i, so we could have just multiplied by an I, and we wouldn't have had to simplify at the end. Again, it doesn't matter because you would have ended up with the same answer, but it probably just would have been a little bit less work. So if you only have the imaginary part, you can just multiply it by I. All right, on the next page, let's look at 39. What can we do to get rid of the I from our denominator here? Multiply by what? What did we say on the last one that we could just multiply by? Just I. So I'm going to multiply the top and the bottom by I. So if you only have the imaginary part on the bottom, you only need to multiply by I. You can multiply by negative 4i. You're just going to end up simplifying at the end. So on top of negative 5i, on the bottom, what's 4i times I? Awesome. It turns into 4i squared. The I squared turns into negative 1, so it's negative 4. Can I simplify this a little bit more? What's a negative divided by a negative? Positive. So it'd turn into positive 5i over 4. All right, let's look at 41. What do I have to multiply to get rid of the I from my denominator?
Negative 2 minus I.
Negative 2 minus I. Perfect. The conjugate. So the first term stays the same. The real number stays the same. The only thing that's changing is the sign in the middle. So negative 2 minus I to the top and the bottom. Do you want to multiply out the top first or the bottom? Let's do the top. How do I multiply the tops together? FOIL. So our first would be 14. The outer would be plus 7I. The inner would be plus 12I. And then the last would be plus 6I squared. Let's simplify this a little bit more. What do we do when we see an I squared? Make it a negative 1, so it changes it to negative 6. Now let's combine our real parts. What's 14 minus 6? 8. Now our imaginary parts, what's 7I plus 12I? 19I. So that's our numerator. All right, let's multiply the bottom now. So on the bottom, we could either FOIL or we can do our conjugate shortcut. Our first term, our A, is going to be negative 2, and our B is I. So it would be negative 2 squared minus I squared. It's always A squared minus B squared. What's negative 2 squared? 4. And what's I squared?
1.
It is negative 1, but negative 1 would turn into a plus 1. Perfect. And 4 plus 1? 5. Can I simplify this? Nope. And is it in standard form?
Yeah.
Yes. So we are done. Any questions? Let's do 43. What do I need to do first?
5 plus 10.
Awesome. We want to multiply it by the conjugate of our denominator. So that would be 5 plus 10I. What do I have to multiply to the top? Same thing. 5 plus 10I. So whatever you multiply to the bottom, you have to multiply to the top too. Let's multiply out the top first. So we need a FOIL. So 10 times 5 is 50. 10 times 10I? 100I. Negative I times 5? Negative 5I. And negative I times 10I? Negative 10I squared. What do we change the I squared to be? Negative 1, so it makes it a plus 10. Awesome. Add the real parts together. So 50 plus 10 is 60. Then we add the imaginary parts together. 100I minus 5I would be plus 95I. Everybody good with foiling out the top? Okay, let's look at the denominator. We could FOIL, or what else can we do?
A squared plus
A squared minus B squared. Our conjugate shortcut. So what's our A? 5. And what's our B? It's always just the number, not the sign. So be careful with the B. It's always just the number. So if you had a negative in front of the 5, your A would be negative 5. But because our conjugate shortcut, they're always going to be 1 plus and 1 minus in the middle. It's always just going to be the number for B. So let's do our shortcut. We have 5 squared minus 10I squared. 5 squared is 25 minus, what's 10I squared? Remember, we square the 10 and square the I. So that would be 100I squared. And what does I squared change to? -1, which makes this a plus. What's 25 plus 100? 125. Can we simplify this?
Yeah.
How? They're all divisible by 5. So let's divide each one by 5. 60 divided by 5 is 12. 95 divided by 5? 19I. 25. Can I simplify it any more? I can? How? Can I divide 19 by 5? So unless you break it apart into 2 fractions, which you don't have to, you can't simplify this anymore because all 3 numbers aren't divisible by the whole thing, by the same thing. So all 3 of these numbers have to be divisible by the same thing in order to simplify it more. You can break it apart into 2 different fractions if you wanted to, but this is fine. You can leave your answer like this. All right, on WebAssign, some of the questions from part 1, one question that people had a lot, there was one where it asked for the real part and the imaginary part. So it was like -1 plus 13I over 11. What would our real part be here? Jade? Perfect. We would break it up into 2 fractions. So we have -1 over 11 plus 13I over 11. So our real part would be -1 over 11. What's our imaginary part?
13 over 11.
On WebAssign, it just wants the number, so it'd just be 13 over 11. So this would be the imaginary. So I think this was kind of the question that people were most confused about yesterday.